Hello everyone. I am Dhruvesh Talati, a senior software engineer with experience in cloud infrastructure and DevSecOps engineering. And I am glad to be here at Conf42 Cube Native 2025. Today I want to talk about something that's becoming increasingly important in the world we live in. Building cloud native systems that are resilient by design, especially for crisis response and recovery. Instead of just reacting when things go wrong, what if we could design systems that are ready for disruption from the start? In this session, we will look at how distributed, elastic, and highly available cloud native architectures can help organizations stay operational during emergencies and bounce back faster afterward. If you look at the world right now with increasingly complicated and frequent events like climate disasters, cyber attacks, and health emergencies, it is evident that the traditional approaches are no longer sufficient. The traditional on premise infrastructures that many organizations still depend on are too slow. When a crisis hits, they take too longer to recover and constantly break down. This simply isn't sustainable when the threats are this serious. The limits of these older systems create big vulnerabilities that can quickly spread and cause problems across entire industries. At this point, resilience isn't just an IT issue, it's a matter of global and societal stability. We absolutely need infrastructure that can flex, scale, and recover as fast as modern crisis demand. So, what does this new infrastructure need to do? I believe there are three pillars to true resilience. First, uninterrupted availability. During an age of constant crisis, this isn't a choice. Basic services ranging from medicine to emergency calls need near perfect time, that is 99.99% availability, to keep people alive and maintain social order. Second, dynamic scalability. Crises are not predictable and can cause stupendous, unplanned surges in demand. Our infrastructures must have the agility to dynamically scale up in seconds, absorbing 10 times capacity increases in minutes. This presents a stark deviation from the latency prone and operationally rigid nature of legacy systems, which struggle to adapt efficiently to dynamic conditions. And third, seamless interoperability. Effective crisis response requires coordinated action by different organizations, public, private sector, and international aid groups. Resilience rests on effective real time collaboration and sharing of data without delay. This is not merely an upgrade, but a foundational strategic imperative to build the resilient and adaptive infrastructure that our future demands. So, how do we build this? We build resilience with cloud native architectures. First, microservices architecture. This pattern releases developer from the limitation of approach. It deconstructs complex applications into small, independently deployable units. When a service fails, it does not take the entire system down, which provides unprecedented resilience and quick recovery. Second, container orchestration. We employ tools like Kubernetes to automatically and dynamically manage our infrastructure. This provides us with dynamic scaling, self healing, and performance optimization across distributed environments, keeping your services up and running and perform optimally. And third, infrastructure as a code. By coding and managing our entire infrastructure with version controlled code, we eliminate human error and deliver consistent, predictable deployment in any cloud or region. This accelerates provisioning considerably and enhances security. Beyond the roots, we use specific distributed resilience patterns to build actually fault tolerant systems. The circuit breaker pattern shields your system from catastrophic crashes. It detects and isolates failing services to cut off cascading failures, leaving core functionality intact and operational. Timeout controls. It prevents the resource exhaustion condition by actively terminating long lived or hung requests. This keeps the entire system stable and allows for a smooth, quick user experience even under high load. Retry and backoff is a master of transient network issues. It uses intelligent retry methods with exponential backoff to retry unsuccessful operations gracefully without overwhelming your infrastructure. And finally, bulkhead isolation prevents critical services from competing for resources. With resource partitioning, failure in one service can't exhaust the resources that your most critical operations depend upon, assuring their continuity, availability, and performance. One of the biggest benefits of cloud native architectures is that they are they inherently have elastic scaling. They offer unparalleled resiliency with dynamic resource scaling. This allows organizations to automatically ingest massive traffic spikes in a disaster without having to incur the cost of over provisioning pricey infrastructure. This is supported by three key abilities: vigilant real time monitoring. We have a continuous pulse on the system with real time insight into performance data, user behavior, and emerging threats, which enables a proactive approach. Smart automated scaling. Our infrastructures are able to scale up or down automatically using dynamic thresholds and predicted analytics, optimally adapting to changing demands. And optimized load distribution. Smart traffic routing maximizes workload distribution between availability zones and regions, bypassing bottlenecks and providing maximum performance. Beyond scaling, uninterrupted service is maintained by building for high availability with redundancy. We utilize strategic multi region deployment to safeguard mission critical applications. By distributing infrastructure across geographically distant locations, we provide unflinching continuity of service even in case of local disasters or catastrophic infrastructure failures. This architecture uses seamless failover through active configurations, which enables seamless zero downtime failover. Strong data integrity is provided with advanced data replication technologies that provides strong consistency in all regions. And efficient traffic flow is achieved with intelligent cross-region traffic steering. This forward-looking paradigm transforms disaster recovery into a proactive capability from a reactive scramble, making it a seamless, always-on experience for end users. The integration of artificial intelligence in cloud native architectures is revolutionizing crisis response by enhancing situational awareness and predictability. AI enables predictive analytics. Machine learning algorithms can analyze historic trends and real time information to foresee crisis escalation and resource requirements before they turn critical. We may also get automated decision support. AI systems provide evidence based recommendations on resource allocation, evacuation routes, and response prioritization under high stress situations. And finally, real time data fusion. AI can combine different sources of data from social media and satellite imagery to sensor networks into consolidated operation intelligence dashboards. In cases of degraded central cloud connectivity, edge computing offers edge side resilience. Assured operational continuity is a key benefit. Edge nodes guarantee the uninterrupted operation of vital systems, enabling critical functionality even when central cloud connectivity is lost. This foundational autonomy ensures resilience in the direct scenarios. Edge computing offers life saving speed too. Local processing offers less than 100 milliseconds near real time responsiveness. This is what's needed in life critical applications such as emergency and instant medicine monitoring, where differences are all in the millisecond order. It also enables unburdening network infrastructure with server side intelligence and data processing locally at the data's point of origin. This mitigates network saturation and ensures that critical communication channels remain operational and performant during high demand crisis scenarios. In a crisis situation, perimeter security frameworks fall apart. That's why a zero trust security model is critical. This architecture is built on three pillars. Continuous verification. It enforces intense continuation verification upon all users, devices, and services everywhere. This eradicates implicit trust and defeats unauthorized access during dynamic crisis scenarios. Strict least privilege. Each user and each system possess just exactly the rights necessary to carry out their function. This restricts lateral movement almost entirely and reduces the effect of potential compromise. Ubiquitous encryption. It offers end to end encryption while data is in transit, at rest, and processing. Your sensitive data remains protected even when the nearby surroundings are hacked. Moving to a crisis resilience enabled cloud native architecture does not occur overnight. A phased migration method is a paramount to success, causing the least disruption while developing capabilities. It begins with assessment and planning, which involves the evaluation of existing infrastructure and the specification of the resilience needs. Second, a proof of concept phase entails running pilot projects on non critical systems in order to prove the architecture decisions. Next, start the core service migration, moving core services with known patterns and practices. Lastly, integration and optimization, linking your legacy and cloud native applications with continuous performance optimization. Effective management of a crisis also demands unwavering government agencies, business community, and global cooperation across partner organizations. Cloud native architecture is the enabler here. They also maintain shared infrastructure via shared cloud platforms. This minimizes duplicate work and provides instant scalable resource allocation during emergencies. They use standardized APIs to unleash real time intelligence and better decision making. APIs facilitate convenient and secure data sharing across various organizational systems with critical information flowing without delay. And finally, they advocate collaborative governance, adaptable shared responsibility frameworks, ensure common security, effective compliance, and effective operational management across all partner organizations, developing trust and collaborative behavior. Adopting this approach leads to tangible, measurable outcomes, accelerated recovery. We can significantly reduce recovery times and accelerate operational restoration, far surpassing the capabilities of traditional infrastructure. Dynamic scaling. It enables unparalleled scaling velocity, rapidly expanding capacity to meet critical demands. Guaranteed availability. It ensures continuous uptime for mission critical services even amidst of major disruptions, and it leads to strategic cost savings by maximizing resource utilization and automating management processes. You unlock substantial cost optimization. Ultimately, this is about more than just technology. Cloud native architectures transform crisis response from reactive damage control to proactive resilience management. This shift enables more equitable service delivery, ensuring that vulnerable populations maintain access to essential services during emergencies. Enhanced interoperability breaks down traditional silos between agencies, creating coordinated response capabilities that can adapt to evolving threats. This result is just not technical resilience, but societal resilience. It creates communities that can withstand, adapt to, and recover from disruption more effectively. Cloud infrastructure is no longer just an IT strategy, it's a cornerstone of societal stability. The convergence of cloud native architectures, AI, edge computing, and zero trust security offers crisis resilience possibilities such as never before. The question isn't whether organizations will adopt these approaches, but how quickly they can transform their infrastructure. I urge you to start with resilience first design principles, build distributed, elastic, and self healing systems from the ground up. Invest in cross sector partnerships to create interoperable platforms that strengthen collective resilience. And embrace continuous improvement. Treat resilience as an evolving capability, not a one time implementation. The time for resilient infrastructure is now. The cost of inaction grows with every crisis. Thank you.